Good morning, guys. I welcome you all for the session. The session is revision session. We'll start with Unit 1. So in Unit 1, we discussed about cement, its type, composition, properties, and IS test procedures. For aggregates, classification, properties, and test procedures. Then about water. These are the topics we discussed. So as you all know, cement is a binding material. The raw materials used for manufacturing of cement is its chemical composition. The proportions are calcium oxide, silicon dioxide, aluminum trioxide, iron oxide, magnesium oxide, alkanes, and silicon trioxide. So the oxides react with each other and chemical compounds are formed. They are called as bogus compounds since it was invented by R.H. Bogus. So these are the four bogus compounds: tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium aluminoferrite. So in addition to this, other compounds also formed. Those are minor compounds. Their influence on the properties of concrete are minor. Hydration, the chemical reaction that takes place between cement and water, is called as hydration of cement. Hydration process determines the quality, quantity, continuity, stability, and rate of formation. Heat of hydration, the reaction of cement and water is exothermic. It liberates heat. The heat is called as heat of hydration. Then various types of cements: ordinary, Portland cement, rapid hardening cement, extra rapid hardening cement, sulfate resisting cement, quick setting cement, low heat cement, air entraining cement, colored cement, hydrophobic, masonry, expansive, oil well, ready set, high alumina. These are all different types of cement we already discussed, and I hope you have submitted your assignment also in the last week. Then about the test on cement. So the test can be field test as well as laboratory test. In the field, open the bag and touch and see. There should not be any lumps. Color should be greenish gray. These are the other procedures. Hope you guys remember all these. Yeah, this is, we have to make a paste, and with that paste make a cake, put it in water and see whether the shape. Then about the laboratory test, sieve analysis, and air permeability apparatus. Blaine's air permeability apparatus also can be used to determine the fineness. This is the air permeability apparatus. Then consistency using Wicket's apparatus. So prepare the paste, fill it in the mold, place it, attach the needle, release the needle, increase the water cement ratio and note down the reading, find the optimum consistency of the cement paste. Then initial and final setting time also same Wicket's apparatus you will be using, but the needle will be different. Then soundness, to determine the soundness, Leach-Atelier apparatus is used. This is the Leach-Atelier apparatus. Compressive strength also can be determined. So depends upon the compressive strength. The cement is graded into 33, 43 and 53. Okay, as usual, compressing testing machine. This is the mold. Then we discuss about the aggregates. So it provides the bulkness to the concrete. It imparts that volume stability, durability. Classification based on the size, it is classified into fine aggregate and coarse aggregate. Fine aggregate, which passes through 4.75 mm ISU. So depends upon the zone, it can be classified into grade 1, grade 2, grade 3. Generally, fine aggregates are classified into natural sand, crushed stone sand. Coarse aggregates are crushed stone, uncrushed gravel, which are retained on 4.75 mm sieve. So, classified based on its shape into rounded aggregate, irregular aggregates. So, this is the irregular aggregates. Angular. Angular one are the perfect one for construction purpose. So, we will be using only flaky and elongated aggregates. I hope you have done this as an experiment in your construction materials lab. This is flaky and elongated aggregates. Depends upon its unit weight. It can be classified into normal weight, heavy weight and light weight. That's about the classification. Then its properties: grading, water absorption, crushing strength, impact strength, and we can include abrasion strength also. So grading by sieve analysis to segregate the aggregates based on its size, both for fine aggregate and coarse aggregate we have used. The experiment, the equipment what it is here is for grading fine aggregates. Water absorption, density basket and pyknometer bottle for fine aggregate. This is for crushing strength determination, crushing strength mold. Hope you guys remember the procedure. Impact strength. So you will be filling the aggregates in this mold and applying that impact load for 15 times. Then you will be sieving and noting down the values. This is abrasion testing machine, Los Angeles abrasion testing machine. Yeah, that's about the test on aggregates. Then about the water. So all potable water can be used for making concrete. So if you have doubt, then the water sample can be tested for its properties. Physical and chemical properties can be assessed. If excessive impurities are there, it affects the setting time, strength, durability, and may even cause efflorescence on the surface, discolorization, and corrosion of steel. So, the property of the water to be analyzed before using it for concrete preparation. So, that's all about the session, guys. Thank you for listening.